Hello, and in this video we're going to be looking at how we can model linear functions from data that we've found in a problem. So we're going to take a look at this example that was on your worksheet. It says that the National Ocean and Atmospheric Administration kept records of annual carbon dioxide concentration in the atmosphere in Hawaii. It's a greenhouse gas. In 1960, the CO2 concentration was 316.9 ppm, and by 2000 the concentration was increased to about 369.4 ppm. All right, in this case we're going to use these variable, the value of x here, or in this case could be time. We're going to let that be the years after 1960, so that means we're not going to use in 1960, but we're going to use 0 for that year. And then after 1960, if you look at year 2000, that's 40 years after, so we're going to use 40 comma 369.4. So the first step on this is to, if we think it's a linear model, is to find the slope using these 2 points. So we're going to do that first. So in this problem, we're going to do the slope formula, which is y2 minus y1 over x2 minus x1. In this case, here are my points. So it's going to be 369.4 minus 316.9 divided by 40 minus 0. So let's look at that. 369.4 minus 316.9, we have 52.5 divided by 40, which is 1.3125. Now we're going to look at this in terms of units. So these values here were ppms, parts per million, and this is years, so this would be parts per million per year, and that means that that's how in this is case 1.3125 parts per million is going to increase that much every year as we go up here, if we're thinking of it as a linear function. Now we can use that to find our equation of our line, looking at y equals mx plus b as your equation. B being the y-intercept, that would be this value here in actuality, because that's when x is 0, and we could actually plug that in just to verify. If it was 316.9, our slope would be 1.3125. X would be 0 plus b, so that means this term would drop out because we had 0 there, and that means that b would be 316.9. So 316.9 is b. So our equation here is y equals 1.3125 x plus 316.9. Now in this case, the 316.9 is kind of our initial value. So we have an initial value plus the amount of increase here per year, and that's our data. Now here it's going to we're going to have more data in between to see how close we are to actually looking at this linear function. So we're going to take a look at that in our graphing utility. Now, in order to graph these in your calculator, you're going to use your stat button here. Your stat button is where we enter in our data under edit, and it also is where we calculate the type of model we're going to use. So first of all, we would start with entering our data in under edit. Now, if these aren't clear in your calculator, you can just go up to the top where it says L1, push clear, and then hit enter, and it should clear all the data in L1 and L2. Now, if you're missing L1 or L2, let's say someone went up here and actually pushed delete, and so you don't see any there. So you can scroll to the right or left, and I don't see L1, L2. And in this case, I deleted L3. They're not really gone. They're just been deleted off the screen. We would have to go second. We have to go to the top, so it's highlighted like that. So it says L4 there, and then we hit second, insert, so that it gives you a blank, and then you can use your L1, L2, and L3 here for on the yellow button keys. So I'm going to insert L3 back in here, hit enter, and then I'm going to hit insert L2, so it's back in there, and then I'm going to insert L1, so it's back in there, and then all of those that I deleted by mistake are now back in here as to go through L6. Okay, now let's put the data in. So we hit 0, 10, oops, clear. Let's try that again. Stat, enter for edit, 0, enter, 10, enter, 20, enter, 30, enter, 40, enter, 50, enter. We'll move over to this list over here, 316.9, enter, 327.7, enter, 338.7, enter, 354.2, enter, 369.4, enter, and 389.8, enter. Now we're going to want to look at this in our scatter plot. So first we have to turn the scatter plot on. So in your calculator, I'm going to go second quit, so I'm out of that screen. The data is still stored in there. It's long, and you can take a look at it again if you just go stat, enter under edit, and you can see our data is still there. I'm going to turn my stat plots on so I can see a stat plot. So I'm going to look at this and make sure that there are no graphs in there. So I've seen this, they're all clear. That's good, because I don't want any graphs showing up besides the plot. Now the plots are right up here. You can see these are the plots. We want to have one of these highlighted or turned on. So we can do that by hitting second stat plot. And there are 3 of them here. You want to hit enter here under this and make sure that this is highlighted on. We want to make sure this is highlighted because that is the scatter plot. If we want to do a connected one, there's that one, there's histogram, and there's some box plots and other things here, cumulative. We need to make sure that these say L1 and L2 because those are the lists that you have there. And I enjoy seeing this mark because it's a little clear for me. You can also use a cross or a small dot. So as long as we've got it turned on, then we can then hit second quit again. Now if we went back to y equals, you can see that this is highlighted. That means it's turned on. Alright, now if we just hit zoom here, or if we hit graph, we would get some data plots, but we have to look and see to make sure the window is big enough to see the data. I wouldn't see any plots in this if I push graph. I don't see any dots at all because my window is not set up for this data right here. So we need to make sure we see 0 through 50 on the X scale here. X scale has to go 0 to 50. Now in this one it says use -5. I probably wouldn't use this many, and 100. I don't know why. We might want to be going looking at 100 here, and then it says 5. So we need to make sure that this scale kind of matches this. It looks like we're going to go out to like double the amount here on the X's. We went 0 to 50, so we're going out double the amount here. So we're going to see about half of them graphed. Now it also says here Y minimum is 300, so we put 300. X maximum is 500, and our scale is 25. We leave the resolution scale alone. In this case, if you look at this, 316 is our low number and 389.8 is our high number. This is in that range. Now we should see a little bit extra on the right hand side where we don't have a graph, because we made these numbers big, so we can see that there's some missing data here. You can see it's pretty close to being linear here. So if we had the graph, it looks pretty close to linear. Alright, so it says, are the data all on a straight line? Well, I'd say they're close. Yeah, close here. They're not exactly a straight line. If you look at this, there is a little bit problematic, and it says, is the general trend somewhat linear? We can say yes here on this, because it does look pretty close to being a straight line there. Use your calculator to find the line of best fit for this data. Give the equation of line of slope intercept form where the coefficients are rounded to 2 decimal places. So what we're going to do is verify maybe that this line up here is close to the line that we think it might be. So that we're going to use our calculator to do that. So that's under, again, statistics, or the stat button, but we're going to go over to calculate menu in order to find the different regressions here. In this case, we're going to use the linear regression, or number 4. If we want a quadratic or a cubic or anything less, or those types, here's another linear one where it reverses those values, A and B. Okay, we're going to use number 4 for linear regression, and we have logarithmic, exponential. We're going to do some of those later in the next video. Alright, so we're going to go linear, hit enter twice. It tells us the coefficients for the slope. A is 1.44 to 2 decimal places, so it's going to be Y equals 1.44. X plus, in this case, B is 313.37. 313.37. That gives us the rounded values. Graph the line of best fit on your calculator. Add the line to your drawing in the equation above. So if we want to graph this, okay, so we would then type in y equals, and we type that in, 1.44 x plus 313.37. That'd be your answer. You push graph. You can see how close it is to the dots. It's a little bit off. It looks like it's pretty good. So we graphed our line of best fit on the scatter plot, and we added it. We can draw it on our drawing on your worksheet as well. What is the y-intercept of the line of best fit? It's 313.37. That means that it thinks that when we started our data set, that's our initial value of the parts per million. For this, they're saying the initial value of parts per million is 313.7. Alright, now we're going to continue this on the next video a little bit, because we're running out of time here on this one.